Okay, now let's look at the next question in exercise 2.2, question number 13. Okay, so first of all, they want you to find the values of L, where L is the limit of xn. Okay, now let's look at part 1. Solving all of you know how to solve this equation. Okay, now in this case, you can also use GC because the question does not specify that you need the exact values of L. Okay, you can use GC, your equation solver, to solve. Alternatively, you can use your graph function. Okay, now how do you launch your graph function? I believe that all of you already know. Just go to menu, just click graph, and then key in your equations to solve. Alternatively, you can use your equation solver. Let's exit this first and go to menu. You can see that you go to equation solver over here. Press F3 to select solver. Now I need to key in my equation. Now the equation I need to solve is actually x minus 4 minus root 15x minus 10 over 4x minus 4 equals to 0. Now just key in this equation into the equation solver. Okay, I'm not going to show you everything, I'm just going to show you partially. Minus 4 minus away, you're going to square root whatever function that you key in 15x. Now carry on to persevere to key in the equation on your own. Okay, I'm not going to do that for you. Okay, and you carry on yourself to key in the complete equation. Equals to, now where is your equal sign in your GC? Press shift dot equals to 0. Okay, I'm just showing you a sample. My equation is not complete, and then you just press execute to solve. Now in this case, the values are slightly different, but if you key in the correct equation and you solve, you should be able to get x equals to 6. Now they ask you to solve the values of x over here. Now they want you to find the value of L. How is this related to the limit L? Now this is the same type of questions that we're solving over and over again. So now let's say that you are given the recurrence relation. This is given in the question. 15xn minus 10 over 4xn minus 4. Okay, now if xn tends to converges to L when n tends to infinity, you are given, okay, xn plus 1 also tends to L when n tends to infinity. So in general, we can say that when n tends to infinity, what happens to this equation here? What happens to this equation when n tends to infinity? Xn plus 1 goes to L, xn also goes to L. So what we have here is L is equal to 4 plus square root of 15L minus 10 over 4L minus 4. It is exactly the same as solving the previous equation. So therefore we can conclude that from above, L is equals to 6. Okay, then we're done for part 1. Easy. Next. Now let's look at part 2. You need to prove this complicated equation which looks very scary, but it's not so scary after all. Now let's write down everything first. Okay, when you first look at the question, it is very tough, but don't panic. We can do it step by step. Now when you're required to show this, okay, you need to prove, want to show this, WTS, want to show. Okay, we always start off from one side of the equation. Now we have already from part 1, we know that L is equals to 6. We have already solved this. Okay, L is equals to 6. So we can substitute this value into the equation. Now when we want to show something, we always start with the one of the sides. So in this case, I start with the left hand side. I copy down what is on the left hand side. Since L is equals to 6, I can substitute inside this equation and I get minus 4. What is the value of xn? Do we have the value of xn? Now look at the expression that I want to show on the right side. The expression I want to show on the right side is purely in the form of xn. So I need to substitute xn plus 1 in terms of xn. So now let's refer back to the question. What was given to us was this recurrence relation that was circled in red. Okay, and we can just replace it into this equation here and we get 4 plus square root 15 xn minus 10. Now don't be afraid, it looks very complicated, but it is not so tough. Minus 4 whole thing square minus 4. Okay, this is of course equals to this. Now what do you notice? Something very beautiful. The 4 can subtract the 4 and eventually you end up with an equation which is 15xn minus 10 divided by 4xn minus 4 minus 4. Now do you know how to show that it's equals to right hand side now? Can you subtract this too? This step I leave it to you to complete. Okay, and at the end you say equals to right hand side and it's shown. Done. Now let's look at part 3. Usually the last part is the hardest of all. Okay, and part 3, they want you to show that if xn is greater than L, then xn plus 1 is less than L. Look at the word hence. Okay, when they say hence, you have to make use of the previous part. So it gives us a clue that we have to make use of part 2. And how are we going to squeeze that out? Okay, xn is greater than L. Okay, not to worry. It's for part 3. Okay, now suppose xn is greater than L. In other words, what is the value of L? We have found it just now. This means xn is greater than 6. We have found this in part 1. Okay, so you want to show that xn plus 1 is less than L. Now, since it's hence, I'm going to take down the previous equation that I have proven. Okay, x plus 1 minus 4 square minus, this is from part 2. Okay, from part 2, I have this, L minus 4 square. Okay, since I have this thing, from part 2, I have this, is, 6 minus xn divided by 4xn minus 4. Okay, I got this expression. Now, if xn is greater than 6, now let's look at it part by part. Okay, let's look at the right hand side first. If xn is greater than 6, 6 minus xn is negative or positive? Less than 0. Agree? If xn is greater than 6, then 4xn minus 4 is greater than 0. Now if we have the fraction, therefore 6 minus xn divided by 4xn minus 4 is less than 0. So since the right hand side is less than 0, xn plus 1 minus 4 square minus L minus 4 square is less than 0. Agree. Okay. Next, L is equals to 6. Let me substitute in. If I substitute in 6, this is minus 4 is less than 0. Xn plus 1, this is simple already. Okay, is less than root 4. Therefore, xn plus 1 is less than 6. What is 6? 6 is the value of L, right? Implies that xn plus 1 is less than L. Done.